Aircraft Monitor, Ecam, provides a display of engine and system parameters and also provides various levels of alerts and memos to the flight crew. The Ecam components used by the flight crew consist of an upper and lower display unit and the Ecam control panel. The upper Ecam display is referred to as the Engine Warning Display, or EWD. The lower Ecam display is referred to as the Systems Display, or SD. The EWD is divided into 4 parts, 2 on the top and 2 on the bottom. The left part of the top section displays the primary engine parameters. The right part of the top section displays the current thrust mode, fuel indications, and the position of the slats and flaps. The bottom sections of the EWD display various messages throughout the flight. These messages are generated by the Flight Warning System, FWS, that include warnings or cautions when a failure occurs, memos for normal operations, special lines for special conditions, and advisories for advisory information. The left part can display primary or independent failures, memos, or config memos. The right part can display the special lines, left part overflow summary, secondary failures, and memos. As soon as the FWS detects a failure, and if the flight phase is not inhibited, the EWD displays the title of the failure and the actions to be taken. In most cases, the blue action line is automatically cleared when the crew performs the action. The FWS divides its functions according to these 10 flight phases. Electrical power on, first engine started, first engine at takeoff power, 80 knots, liftoff, 1,500 feet or 2 minutes after liftoff, 800 feet on descent, touchdown, 80 knots, second engine shut down, and 5 minutes after shutdown. The FWS is designed to not display certain alerts during some phases of flight. This is to ensure that non-critical items do not become distracting during high workload periods, such as during takeoff or landing. When the takeoff and landing inhibits are in effect, you will see magenta memos on the right side. These appear as takeoff inhibit during phases 3, 4, and 5, or landing inhibit during phases 7 and 8. Other specific inhibits are in effect during certain phases according to each aircraft system. At the end of each section of each chapter of the Ecam, a list of the related systems warnings and cautions is provided, along with a list of the phases when they are inhibited. There are 2 conditions for a failure to occur as it relates to Ecam inhibit. 1. A failure can occur before an inhibited phase and continue into and through that phase. 2. A failure can occur during an inhibited phase and continue after that phase. If a failure occurs prior to an inhibited phase, shown here as phase 3, the EWD displays the warning immediately and will also continue to display it during the inhibited phase and until it is corrected or the crew has cleared it from Ecam. If a failure occurs during an inhibited phase, the EWD will not display the warning until the aircraft enters the phase where the warning is not inhibited, shown here as phase 6. After the warning is displayed, it remains until it is corrected or the crew has cleared it from Ecam. Ecam color conventions indicate the importance of the failure or indication. In general, red indicates a configuration or failure that requires immediate action. Amber indicates that the crew should be aware of the configuration or failure but needs not take immediate action. Green indicates an item that is operating normally. White is used for titles and remarks that guide the crew to execute various procedures. Blue is used to display actions to be carried out by the crew or limitations. Magenta indicates messages that apply to particular pieces of equipment or situations, like the aforementioned inhibition messages. There are 3 priority levels for warnings and cautions that are detected by the flight warning system. These levels determine the priority of appearance on the EWD and are labeled Levels 1, 2, and 3. A Level 3 warning has priority over a Level 2 caution, which has priority over a Level 1 caution, and will appear in that order if occurring simultaneously. Additionally, there is a hierarchy of priority within the Level 3 warnings. Oral warnings also have a hierarchy of priorities. Synthetic voice has priority over all other oral warnings. Oral warnings temporarily interrupt kettle, buzzer, etc., plus or minus 1 second. Single chimes are limited to 1 every 2 seconds. A Level 1 caution is the lowest priority and has no oral alert or master caution. It appears as an amber caution on the EWD without displaying a system page on the SD. This level requires crew monitoring only and indicates a loss of redundancy or system degradation. A Level 2 caution is the next priority and is normally accompanied by a single chime. The master caution lights illuminate steady, an amber caution appears on the EWD, and the associated system page appears on the SD. This level requires the crew to be aware of the configuration or failure, but may not necessarily require immediate action. A Level 3 warning is the highest priority warning, and it is normally accompanied by a repetitive chime, CRC, or a specific oral alert. Additionally, the Level 3 warnings cause the master warning light to flash, a red warning appears on the EWD, and the associated system page appears on the SD. This level requires immediate action by the crew, as the aircraft is either in a dangerous flight condition or has a system failure that affects flight safety. There are 3 types of Ecam failures: independent, primary, and secondary. An independent failure affects a component of a system that causes the component to fail or operate at a degraded level without affecting other components or systems. An independent failure appears in amber on the left memo page on the same line as the item title of the system. A primary failure affects a system or a component of a system that causes other components or systems to fail or operate at a degraded level. A primary failure appears on the left memo page in red or amber on the same line as the item title of the system and has a box around the failure. Secondary failures are the loss of a system or a degraded level of operation of a component in that system that is a result of a primary failure. A secondary failure appears on the right memo page in amber, preceded by an asterisk, and lists only the systems affected and not the component. Usually more than one secondary failure is caused by a single primary failure. Shown here is an example of an advisory. Advisories are provided when systems parameters should be monitored. An advisory is indicated by an automatic display of the related system page on the SD, with the item title pulsing normal white to bright white, and the affected parameter pulsing green to bright green. Shown here is an example of a memo. Memos are green for temporary normal operations, but can be amber for abnormal conditions. During normal cruise, there should be no memos. The takeoff and landing memos display the key items for takeoff and landing. The takeoff memo appears 2 minutes after engine start or when the takeoff config push button is pressed, provided at least one engine is running. Each takeoff memo item is displayed in green with the action item in cyan until the correct configuration for that item is selected, and when the correct configuration is selected, the action item appears green. The takeoff config line is the last line of the takeoff memo. The takeoff config test cyan will change to takeoff config normal green when a configuration test is performed if the correct responses for all items are set for takeoff green. If the configuration of an item on the list subsequently becomes abnormal, both the takeoff config and item green response indications will revert to cyan. The function of the takeoff memo is only to ensure that the listed items are properly set for a normal takeoff. It does not ensure a safe takeoff configuration for the aircraft. However, the function of the takeoff config test is to ensure that the aircraft is safely configured for takeoff. None of the items on the takeoff memo will cause a config warning if incorrectly set, except the flaps configuration. If the flaps are positioned at a position other than takeoff 1, 2, or 3, the response will be a cyan blue response, and a config warning will sound if the takeoff config push button is pressed. The takeoff config test simulates takeoff power and checks for slats flap not in takeoff config, pitch trim not in takeoff range, rudder trim not in range, speed brake not retracted, side stick fault, brakes hot, doors. Additionally, if takeoff power is set, takeoff config test also checks for park brake on, flex temp not set. The takeoff memo remains in view until takeoff power is applied. The landing memo appears during approach at 2,000 feet AGL. It will not appear until 750 feet AGL if 2,000 feet AGL is not exceeded after takeoff, such as during an immediate return. The landing memo flaps full action item will display as flaps config 3 if the aircraft flight controls are operating in alternate or direct law modes, or if the GPWS landing flap 3 push button is on. This completes our discussion of the takeoff and landing memos. System display and status. The system display and status appear on the lower Ecam. There are 11 system display pages available, and certain pages appear automatically depending on the phase of flight. The system display page can be automatically called up as a result of an abnormal condition. Regardless of which page is displayed, the crew can manually select a system display at any time by pressing a push button on the Ecam control panel. On the bottom of the SD, there are permanent display items as shown here. They are the TAT, SAT, UTC, and gross weight. Additionally, if the G-load is less than 0.7 or greater than plus 1.4, the G-load will be displayed. We'll now sequence through a normal flight and describe the normal systems pages that automatically appear according to this diagram. This diagram shows the 10 phases of flight. For example, when electrical power is applied to the aircraft, electrical power phase 1, the doors page is displayed to allow the crew to monitor the aircraft doors and the flight crew oxygen system. When the APU master switch is selected on, the APU page appears and remains displayed until 10 seconds after the APU RPM has been above 95% for 10 seconds, or until the master switch is selected off. When the APU page blanks, the doors page will reappear. When the pilot initiates the engine start, the engine page appears. It remains displayed until 10 seconds after the end of the start sequence, when the engine mode selector is set to norm. After start, when the engine displays blanks, the wheel page automatically appears to allow the crew to monitor these items during taxi. When either pilot moves the side stick more than 3 degrees in pitch or roll, or when rudder pedal deflection is more than 22 degrees, the flight control page temporarily replaces the wheel page. This automatic display change allows viewing of the flight control page for the flight control test, and the wheel page then reappears after 20 seconds. When the first engine reaches takeoff power, the engine page is displayed. If there are no Ecam failures, it remains displayed until climbing through 1,500 feet, when it is replaced by the cruise page. The cruise page shows a combination of engine, air, vibe, and cab pressurization items to make it easy for the crew to monitor these items during the flight. The cruise page is displayed until the landing gear is extended, at which time it is replaced by the wheel page. Normally, the APU is started after landing, and the APU page displays until the APU start cycle is completed. Then the wheel page reappears. The wheel page displays until it is replaced by the door page when the last engine is shut down. The pilot can manually select any other page by pressing a SD push button. When a SD is called up that is not the normal system page for the phase of flight, the selected SD push button light illuminates. This light is a reminder that a page has been manually selected. To return to the normal page for the phase of flight, in this case doors, the pilot can press the illuminated push button or press a clear push button. Regardless of the system displayed at any time, an automatic call-up of an SD page occurs when a fault or malfunction triggers a caution or warning message. At the same time, the appropriate warning or caution message appears. If appropriate, an oral alert sounds and the master warning or caution lights come on. Additionally, the clear push buttons illuminate and a local light on a system panel may illuminate. After completing each procedure, the crew will push the clear push button until all actions and procedures are completed. At this time, the memo displays return to normal. The phase of flight page is displayed, and the clear push button light goes out. A system page may also display automatically when an advisory appears because a parameter is out of range. In this case, the parameter will pulse in green while it is outside limits. Additionally, the SD title will display flashing intensity from normal to bright. Advisories are inhibited during some phases of flight. Status page. The status page displays an operational summary of the aircraft status after the engine warning display has displayed a failure and the crew has completed all pages associated with that failure. Assume this display is the last in a series of pages for a failure. Push the clear push button one more time and the status page will automatically appear. The status page displays the messages of the effects of an FWS detected fault or reduced capability. Limitations are in cyan. Approach procedures in white, red, or amber. Corrections to apply for landing in cyan. Other information in green. Canceled cautions in white. INOPSIS in amber. And the Class 2 maintenance items in white. If more messages are applicable than can be displayed, the overflow arrow appears and the crew can view those messages by pressing a clear key. The status page also appears automatically during flight when the flat panel is positioned at 1 if the status page holds messages other than canceled caution or the maintenance part. In this case, the engine warning display screen displays the boxed STS reminder. If the status page holds Class 2 messages in the maintenance part after engine shutdown, the STS reminder flashes on the engine warning display screen. The screen displays the maintenance part only when on the ground before engine start or after engine shutdown, phases 1 and 10. We will now show the sequence of displays that appear when the blue hydraulic reservoir overheats. We begin with the normal display. The aircraft is climbing with the center tank feeding and the wing anti-ice is on. Notice the cruise system page is displayed and notice other normal parameters. Ecam automatically calls up the hydraulic systems page to display a synoptic of the hydraulic system. Notice that overheat is displayed in amber for the blue system. The action on the engine warning display instructs the crew to turn off the blue electric pump. The crew has selected the blue electric pump off, and the blue system now has low pressure. When the blue hydraulic system loses pressure when the pump is turned off, hydraulic blue sys low press appears as a primary failure. The master caution lights remain on, as does the push-button fault light on the overhead panel. On the right side of the engine warning display, you see the secondary failure result is a loss of some flight control items. The clear push button remains lighted, so one of the crew will push it. When the clear push button has been pushed, the hydraulic messages disappear from the engine warning display, and the flight control systems page is displayed. The flight control surface actuators that are depressurized as a result of our action are shown in amber. The clear push button is still lighted and the overhead light is still on, so one of the crew will push it. The memo area on the engine warning display returns to normal and the status page appears on the SD to display the procedures for completing the flight with the faulty blue hydraulic system. The clear and STS push buttons are now lighted, so one of the crew pushes the clear button a third time. The clear push button light now goes off, the appropriate SD page is displayed, in this case cruise, and the STS reminder appears on the engine warning display to remind the crew of the available status page information. The overhead light remains on until the condition is corrected. This sequence has provided an example of the Ecam operation during an abnormal condition. DU failures. If the upper DU fails or is switched off, the engine warning display has priority and automatically moves down to the lower DU. During the single display operation, if the flight crew desires to display the SD or status pages, the desired SD or status page push button can be selected to temporarily display it on the lower DU for a maximum of 3 minutes. When the push button is released, the engine warning display is again displayed. We're now back to normal when a failure of the lower DU occurs or the lower DU is switched off. As before, the crew can push and hold the desired systems page push button to temporarily display the SD or status page on the upper DU for a maximum of 3 minutes. When the push button is released, the engine warning display is displayed. Another way to display the SD or status pages when the lower DU has failed or is off is to select the Ecam ND transfer switch on the switching panel to display it on the NDU. We're now back to normal when a failure of both DUs occurs. The crew can use the Ecam ND transfer on the switching panel to display the engine warning display on a navigation display, and if necessary, can push and hold a system page push button to temporarily display the system status page on an ND for a maximum of 3 minutes. Let's answer those questions.